because, okay, one question, ladies. Jacket or lab coat for making a video?
Lab coat.
Lab coat. All right, it looks more sciencey. Okay, so here's what I'm gonna ask y'all to do, because this is your guinea pigs, okay? Science class. We're gonna experiment on you. I'm gonna record this as I told you. The plan is to, have a video that when people need help, we can go to this video first, okay? Because I'm not gonna say I teach this like the only way it can be taught, but I've found some success in teaching it this way. And then if students know who I am, maybe they'll be like, oh, I know who that guy is, I'll watch that video. So here's what I'd love for you to do if you're willing. Also get out your cameras. And you don't have to, but if you'd be willing to video each other doing problems or whatever, just shoot whatever you want, but kind of adding it to the collection. We might take some of those shots and then put them in. I joked with Mr. J, I was like, I need to put like GoPros on all their heads, so, but we don't have this. So. And you guys would be like, no, I'm not doing that. Okay, we're gonna do unit conversions.
So where like video I still want to work?
Yeah, if possible. Like, here are the kinds of things we want to see. We want to see questions. Now, the camera will probably be able to hear you. It will be able to hear you, but it won't see who's talking. But I'd love to see questions. If I could have, we would have what's called a 2 or a 3 shot, meaning 2 or 3 cameras shooting from different angles, so that when someone's talking, we could go to that person and kind of cut to that person and go like, oh, that's that person asking a question. I only got a 1 shot right now. And really, this is an experiment. I'm hoping, I've been wanting to do this for a long time to kind of add to our catalog of stuff. So right now, there aren't really any wrong answers, just shoot. If you want to, if you don't want to, that's totally fine. If you're willing to shoot and share your footage, then it might make it into our video. But this also might just be a thing where Mr. J and I go like, okay, here's what we should do differently next time. Cool? Okay, so all that said, the thing I always ask is this. Are there any questions before we start? We're here for unit conversion, right? Does anybody have any particular thing other than like, I just don't know how to do this? Okay. Oh, so shots we would want. Shots of questions, also shots of successes, also super importantly, shots of mistakes. Most of science is about failing forward. Most hypotheses are wrong. I'm gonna say that again. Most hypotheses are wrong. We do an experiment, we find out, that wasn't right. But then we publish and we show what we tested, and that answers a question. Hey, I don't know what the answer is, but I now know it's not that. And because I published, so does everybody else. That's super important. It's weird to me that Nobel Prizes are never given for most famous failed hypothesis, since it's so important to science. But they're not, because we only hear about success or whatever. Okay, so failing forward is fine. Making mistakes is to be expected. I couldn't do this either. Part of the reason I teach it the way I teach it is because I spent a long time not doing it correctly, and it wasn't until I was teaching it that I kind of really got it, okay? So, I know how to probably address mistakes, at least I made, but I've seen them be very common. So let's start with, what's the point of unit conversion? Anyone? And now would be a great time to phone that person answering. But wait. Oh, do we have another person? What is unit conversion? Just take a shot at it. Remember, we're failing forward. It doesn't matter if you're wrong. It's okay. In fact, if we find out you're wrong, that's a piece of information we know, so I can correct it, right? If you all knew all of this already, I would be out of a job. So let's not have you know it all already, because I have to feed my child. What do you think unit conversion is about? Just take your best stab at it.
Converting one unit to a different one.
Okay, give me an example of that. The common one you're doing right now that you're struggling with is converting from units that you're familiar with, like feet and inches, to what?
Metric unit?
Yeah, to units you're not as familiar with, like meters and centimeters, okay? What's it? Oh, that was a yawn. Now the reason we're swapping, now part of this is switching from metric, from what's called the imperial system, which empires used, to the metric system, okay? Do you know how many people use the imperial system now, for countrywide? How many groups, how many countries? A guess? You want to guess? The system we use.
Isn't it just us?
No, there's one other country, Liberia, who famously has situations where to buy bread, they literally have to bring a wheelbarrow full of money. So in other words, they're not exactly necessarily the best company to be in for awesome decisions. Ooh, I'm gonna draw this in a different color. The metric system is just better. I mean, it's just I don't say that about lots of things. I'm pretty like, oh, well, there's advantages, disadvantages. But it's, as far as making sort of measurements and decisions, it's just pretty demonstrably better, okay? Here are the reasons. Everything is in tens all the time. There are no fractions really, because you just do tens. Everything is set up so that when you convert from, so one is we're converting from imperial to metric. You're doing that in your brains right now. You're trying to learn this, you have to learn how to translate from this to this. You have to learn how to speak these units. Okay, you have to learn a centimeter is about that. A meter is about that, kind of. This is gonna be our meter. It's not exactly right, but we're gonna pretend. So you're doing that conversion, but sometimes we also need to convert from like within the metric system from one unit to another for some reason, from one distance unit to another, or sometimes from like a volume to a different kind of unit. The super awesome part, I'm gonna explain what I mean by that, is that this is set up to do that super easily. This was just kind of arrived at by accident over time, okay? The reason a foot is unit of measure in the imperial system is because people would literally measure with their foot. What's the immediate problem with that?
People don't have the same size foot.
People don't have the same size foot, so you'd have to standardize it somehow. So they standardize it to a certain thing. The reason an inch is because it's about that. Now, if two builders are working on the same house and had different size hands and fingers, we got a problem, right? Now they might have to do some converting. Well, I know John's foot's about this much bigger than my foot, so whatever, right? Okay, so then what happened is, this was just kind of like accidental, oh, we standardized some measurements we happen to use. There's 12 inches in a foot. Why 12? Everything else we do is tens. Anybody know that? Because of the Phoenicians, of course. Everybody knows this, right? No. The Phoenicians, from whom our alphabet comes, also used what's called a base 12 system of numbers. Meaning instead of going 0 through 9 and then starting over at 0 again, which is really what 10 is, right? Starting over at a different kind of 0. They go 0 to 11 and then start over again. Which is why there's all these 12s and stuff, like clocks, and really time is 60 minutes, which has to do with 12s also. Kind of wacky, right? Okay, so that's the setup. What we're doing is this. This is about about a yard, which is how big in the imperial system. And when I say how big, I'm asking you to convert it to a different kind of unit. A yard is how many feet? 3 feet. Oh no, wrong color. How many inches in a foot? 12 for some reason. 6 exactly half 12, yes. Now, one thing I actually just demonstrated is why 12s are sometimes better. They're more divisible evenly by a bunch of things. 12s are divisible by 2, 3, 4, and 6, and 12, I guess. Whereas 10s are only divisible evenly by 2 and 5, right? That's it. Okay. what's the basic unit of measurement in the imperial system then? Is it the inch, is it the foot? I mean, I'd maybe say the foot, kind of. It depends on it probably depends on what you're doing. If you're in fabric, it's usually yards. You buy cloth by the yard. Interestingly, we can't agree on some things like a dozen, and then there's a baker's dozen, which is a different number. I think it's 14. May know that, or 13? Yeah, a baker's dozen is a different number than our normal dozen, right, which is 12, again, Phoenicians. Okay, so this is measured into the basic unit of measure for the metric system is the meter. Now, when I say basic unit of, the reason I'm saying that is when the people who designed this system, who were philosophers and scientists, who were like, hey, did you ever notice how changing from one thing to another in this system is awful? For example, if the basic unit of measure for a distance is a foot, what's the basic unit of measure for a volume? In other words, an amount of liquid or a space contained.
Meter?
A liter?
Yeah.
That's metric. Actually works
Oh,
great.
When you're talking about that.
No, no, in this one. Ounces or maybe gallons or maybe pints. Do you know how many ounces are in a pint?
8.
16, 8 in a cup. Ounce. 8 is a cup. 16 is a pint. 2 pints in a quart, which means 32 in a quart. And 4 quarts in a gallon, which means 128. Everybody remembers that, right? Now, if we were going to convert to a different kind of volume, like length by width by height, which is also a different way of measuring volume, right? Because a certain amount of liquid will fit in that volume, right? And we said foot was about the kind of regular unit. How many gallons in a cubic foot? That face is what I wanted to see, which was the face of, what? If this is a foot on a side, somebody look this up for me, because I don't know. It's not a gallon.
What's the question?
How many gallons of water in a cubic foot? I know that 1 pint weighs almost, but not quite, 1 pound. 1 pound of water weighs almost 1 pound, but not quite.
7.48 US gallons of water.
7 point what?
48.
48, because of course you would remember that. The reason is none of these things, these just like happened. And then people just kept using them. In the metric system, 1 cubic centimeter is exactly 1 milliliter. Because they designed it that way. Everything converts from one thing to another in a very rational and easy way, because instead of just using stuff that people had come up with over centuries, which is fine. I mean, we were measuring things, we were like, hey, let's measure this, let's measure that. We didn't come up with the same thing. Totally fine. But then eventually these people were like, what if we rearranged it all so it's exactly the same? 1 degree Celsius is equivalent to, there are 100 of them from 0 to 100 in freezing water to boiling water. They picked that because water is super common. Now this is at sea level, but most people live pretty close to sea level, so it works. The amount of energy it takes to raise water, one milliliter of water 1 degree, is called a Newton, I think. I have to check that. So everything is like in very easy ratios. So you don't have to remember like, oh yeah, of course a cubic foot's 7.48 gallons. Like, who doesn't remember that? Okay? So this is my demonstration to you quickly of why the metric system's just better. When I was much younger than you, when I was 6, 7, we were converting to the metric system. And then there was a presidential change and all that stopped. That was in 1982. Okay. Now, all that said, let's talk about this conversion thing, okay? Because sometimes you're converting from this to this, and sometimes you're converting from a big unit to a smaller unit within the same system, and sometimes we'll be converting from milliliters to cubic centimeters. Now, once you get in the metric system, all that becomes super easy, because if you know the milliliters, you instantly know the cubic centimeters because it's the same. Awesome. But you may get conversions from here to here, okay? You may get conversions from a longer length to a smaller length. We're gonna practice one, okay? That's what we're doing, okay? Now, all that said, here's the thing. If we measure a shoe, and let's pretend this shoe is the shoe of whoever was the standard for 1 foot. If we measure it in inches, will it be a different physical size? In other words, will it change if we measure it in centimeters? I'm seeing head shaking. You don't think it'll change? You think it'll be the same foot, same shoe? I agree. I want everybody to remember that, because the most common mistake I see, and this is going to lead to Chesser's rule number 1 of 2, how to do metric conversions to keep in mind, is remember that the size of whatever you're converting never changes. And I say that because the most common thing is a student will do a conversion and they kind of think they've got a feel for it, and they're not following the steps, and they're not writing everything out. And I'll say, convert 26 centimeters per hour to the units kilometers per second. 26 centimeters, how long is a centimeter about? Kind of, you don't have to just get kind of close. Like that, kind of. 26 an hour. Super fast? Super slow? Pretty slow, right? Pretty slow. They'll give me back a number like, yeah, that's 3,600 kilometers per hour. You're smiling, why? That's super fast. First of all, it's gonna be 2.6 something because everything we just moved decimals. So the number shouldn't change. But then also, that's super fast. And they'll just be like, yeah, there's the answer. And I'll be like, are you sure that's the answer? And so they're telling me, here's the thing about this foot. When I measure it in the imperial system, it's this big. But when I measure it with this, it changes size crazily, right? But I want you to be thinking about that and aware of it all the time, because it's going to let you do rule number 1, which I almost never say to do in science. Okay, this is one of the only times I say to do this. And it's to do a gut check. To just kind of go like, does that sound right in here? Because most of the time in science, this is wrong. You should be using this, because it's way better at logic, okay? But in this case, I want you to do a gut check. So the very first thing I want you to do when you're doing a unit conversion is to think kind of hard about, hey, like, about how big is this? Or about how fast is this? Or about how much stuff is this? Now that's a little hard because you don't have a feel for how big these things are because you're not used to working in them, right? Which is why you can always use the metric step conversion chart, okay? And I just want you to start thinking about like, well, if a meter's just over 3 feet, then some number of centimeters less than 100 is definitely less than 3 feet, okay? This is 1/4 of a meter. quarter of a meter every hour, that's way slower than a snail's pace. Really slow. So at the end, you give me a smile like, and that's the exact same smile I try not to do when a student gives me that. I'm like, I'm not gonna smile, I'm just sure about that number. The very first thing you have to do is gut check. Okay? Does this sound like it could possibly be right? Because the quantity does not change. Now, I'm going to pause and see, are there any questions so far? This is more than you thought you were going to get, right? You thought, he's going to give me some equations and I'm going to go home. But my problem that happened in my head was, I didn't know what was happening when we were doing unit conversions. I was like, I don't know, he told me to change it from one set of letters to another, but I don't really know what's happening. I find it helpful if you really know what's happening. So I want you to imagine what's being measured and do a gut check. One of the only times I will ask you to do this in science. Okay. No questions on that. I'm going to erase some stuff then, okay? Have I demonstrated the metric system is better? Do we agree on that? Yeah. So you guys are about to be all the voters. So why don't you make that happen? It's going to cost some money, but I promise you it will save more than it costs, not even in the long run, in like the medium run. In the short run, it'll be kind of expensive, and then after that, everything better. By the way, you know who else uses the metric system all the time? The United States military. Because it's better. The first thing you learn in the military is, they'll say like, that's about 20 clicks. That's 20 kilometers. They use everything metric because it's better. So let's just get rid of this. Remember, we're always measuring the same size thing now. Now, let's talk about that problem I just wrote up there. 26 centimeters per hour. Convert to kilometers per second. The next super common problem you have is, hey, I don't know what meters, kilometers, centimeters are like, right? And that's where the step conversion chart comes in, which this was not a thing, I don't think, or I don't remember it. Really, the schools I went to could not have cared less about the metric system, so they didn't really teach this. So maybe it existed, but I didn't know. But there was no internet yet. There was literally no internet yet. It wasn't even something I didn't know about. So anyway, I didn't know about it. The way this works is, put your base unit in a middle step here somewhere. Okay, so base unit is a part you have to kind of memorize unless you have a step chart that has it on it. The base unit is meter for distance. What is it for volume? You said it earlier.
Liter.
And the way, by the way, to tell if you've got the base unit is it won't have a prefix like kilo or deci. It'll just be the word. What else? What are some other base units? Anybody know any? Nice thing about, they didn't switch time, interestingly. I don't know why they didn't switch to 100 seconds, but they just didn't. So time is still the second. Or, it's the same seconds, minutes, and hours you're used to. So we take the base unit, and we do this. Going up, we have something called deca, which means times 10. And kilo, oops, put it in a different place here. Kilo, which means times, well, all these are times 10, okay, because it's time 10, so we go up. So kilo means 1,000. Deca means 10. I don't remember this one. If anybody wants to look it up, I'd appreciate it. Then going down, we have times 0.1 every time. or divide by 10, which is the same thing. So this is deci, and this is centi. Anybody know this one? More legs than a centipede. You think it means million, but it actually means thousand, million. Okay? So you can use one of these to start to think of like, well, how big is that? So you start in a base unit like meter. A meter is a little over 3 feet. 100 meters is about a football field if you include the end zones. Okay? Sort of.
Is that Topham KIB?
Kilo.
Oh,
My bad handwriting, sorry.
no, you're fine.
You can look this up too, okay?
Mhm.
Just look up metric step chart. It's okay with me if you use that. So the way this works is no matter what unit you're given, you work your way back to the base unit and you need to know something about the base unit. You know about how much a liter is, right? You've bought a liter of Coke. Typically they come in 2 liters, but you can buy them in a liter, right? But if you think 2 liter, about half that. So a liter, okay, well, what's a centiliter then? More or less than a liter? Less. It's 1/100th, okay? It will go down a step, there's 1/10, go down a step, there's 1/100th, okay? Kiloliters would be 1,000 liters, so that's more than you want to drink in a sitting. You would die. You can't even do it. Even decaliters you should probably avoid. 10 liters of soda, even 10 liters of, did you know if you drink too much water you can die? It's a thing. A lot of people don't know that. Okay, so you take your base unit or whatever unit you're getting and work your way back to the base length so you can get an idea like, hey, about how big is this? Or about how much stuff are we talking about? Or about how fast is this? Okay? So that's one thing I want you to do. And then, what was rule 1, by the way?
Check your gun.
Gotcha. Now we're ready for rule 2, and we're actually getting ready to solve a problem. And once we solve this problem and you do a couple, I think this will all sew up and you'll go like, oh, I think I can do this now. I hope. So rule 1 is gut check, and rule 2 is, remember what I said earlier, if you measure the thing, if you measure someone's shoe in imperial, then you measure it in metric. Or if you measure it in meters, but then you decide, I think I'm going to measure it in centimeters instead. 7, 8, 9. Does it change? Does the shoe change size? No. So this is the other rule that I really got lost on part of this, and I'm going to explain. All we're doing when we convert, because we need it to stay the same size, is multiplying by a special, oops, you can't write, a special case of 1. If you multiply something by 1, what are you always going to get? Itself. Whatever the equal, right? Now remember, the size shouldn't change. The shoe doesn't change size. So when we convert, we better get an equivalent amount. It's just being measured in a different number. It's like saying, hey, how many inches in a foot?
12.
You just converted from feet to inches. You told me 1 foot is the same as 12 inches. That's really all we're doing. Don't overcomplicate it, okay? What happens is people go like, I don't know what these unit means, and I don't know what's happening, and things are crazy, and then they give me really slow speed into a really fast speed, and they have no idea that they just did that. Now you smile, because you were like, that doesn't seem right. Number 1, gut check. Number 2, all we're really doing is multiplying by a special case of 1, and really all you have to figure out, that's kind of the hardest part, is what special case of 1, or several special cases of 1, do I have to multiply by to shift this over to the units I want to earn? And this is the part where avoid my mistake, avoid thinking you can do it in your head, because I always thought I could do it in my head, and then I would drop something, and I would be the kid who would then be like, oh yeah, it's 36,000 kilometers per second. Because, oops. No, that's not right. Okay, so, let's talk about how to do that. Multiply by a special case of 1. 26 centimeters an hour, here's 20 centimeters. Or about. So about that much space in an hour. So we better not come back with something super fast. This better be really slow in the end. And it better be equivalent of that much space in 1 hour, because it needs to all be equal at the end. I'm going to erase this. Okay. This was black. How many centimeters? Now you're going to use that. Oh, no, let's do this first. Let's do this first. New colors. Would you say that statement is mathematically true? Everybody? That easy? That was easy. Wait a minute. But what about this statement? How about now? You're still saying yes. You're like,
Does mean something?
I'm just using the designate so we can keep track of which one's which. But no, other than that, they don't mean anything. Good question, though. No, she's like, wait a minute, you changed something. But yes, this is 5 things and this is 5 things. They're equal. Okay? Okay, wait. What does that equal? I got a finger, not that finger, 1. Anybody else? Agree? 1. Okay, now here's where it gets tricky, okay? What does that equal? Are you sure? What about colors over here?
Will it make a different color?
No, but I mean,
Oh, yeah.
does it equal 1?
Yeah, it will be.
Okay, now, this is the part where I'm going to throw you, okay? You ready? How about this? What about that one? Does that still equal 1? Yes? But I revert, you notice that I reversed them. You're still sure about that?
They're
They're
the same number.
the same number. That thing right there was the thing I couldn't understand. But let me give you an example of why, and you'll give me a little bit of slack, I hope. Okay? We agree on all those things, right? So I'm going to erase them. How many centimeters does 1 meter equal? You told me feet and inches just a second ago, but this is the part where people get thrown because they're like, oh crap, I don't know this metric stuff. But you could use this now to tell me real quickly, if that's a meter, how many centimeters in a meter? 100? She says 100. Point. 100.
Or 0.001.
0.001.
I'm sorry.
No, that's okay. This is the reason you're here. If you knew it already, you wouldn't need to be here, right? Well, let's check. If this is 1 meter, and we're in centimeters, okay? Are centimeters smaller or larger than meters?
They're smaller.
Okay, so are there gonna be more of them or less of them to make up one of those? Now think about inches and feet when you think about this. Which one's,
More.
there have to be more of them. So what did you say at first?
100.
And you were correct. There are 10 decimeters in a meter. That's those big marks I made, the 10 big marks. And there are 100, well, there are 10 centimeters in each decimeter, so that means there are 10 times 10 equals 1. There are 100 centimeters. in case of doubt, think about how many cents are in a dollar and how many years are in a century, because these are all Latin words that mean hundreds, thousands, tens. The decimal point literally means the point after which the next unit is 1/10 of that. So you said 100. Does everybody agree that 1 meter equals 100 centimeters? Now, if that's true, what does that equal?
One,
Yes, why?
because they're equal.
Anything divided by its equivalent is 1. What's rule number 2? All you're doing is multiplying by special cases of 1, because remember, the end quantity better be the same because the shoe didn't change size. Now, here's the part where I am going to hopefully throw you. Because if I don't, I'm the only stupid one in the room. Or I'm a good teacher. I guess I could be. What does that equal?
I think it's gonna equal 1,
But you're not sure.
Yeah.
Because that 100's on top now. It's confusing, right? The colors are different. Yeah. She's the philosopher over here. She's like, you changed something. What about everybody else? Let's get some group thought in here.
One.
1. But I was in your shoes because I spent all this time in school going, I don't remember which one I'm supposed to put on top. I don't know. And the answer is either one because they're equal to each other, which is why I did the business with the different color 5s. Now you get it. There's a method to my madness. All you're gonna do is multiply by a special case of the number 1. And you get to choose, hey, what's most useful to me right now? To put centimeters in the top or meters? Why would you want to put one of these in the top or bottom? To me to know that?
To decide which one you're solving to get the, you put the centimeters on top, correct?
Yeah,
Because
well-
you've got that.
Well, what unit are we trying to kill? That's the next
The
question.
centimeter.
Yeah, so where do we need to put centimeters multiplied by a special case of 1 to kill off centimeters? If I put centimeters on top, it's gonna be centimeters squared.
The bottom.
The bottom, so I can strike it out,
Yeah.
okay? So does everybody agree with this? Okay, now we're ready to multiply by a special case of 1. So we're gonna solve this. Now, this is the other thing. A mathematician, and you go watch Ms. Rathbone or Dr. Wilson do this, and you will see them do the following. They'll multiply by a whole bunch of special cases of 1 all at once. They'll set the whole problem up and then go, strike, bam, 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 boom, and here's your answer, ha ha! And I'm always like, whoa, that was way too fast, I don't know what's going on. Scientists will do that too. I'm encouraging you to walk before you can run. Just convert from one thing to another at a time. It'll be slower, but you'll be way more confident that that's your answer, okay? Now, when you get really good at it, start doing wacky stuff where you have a giant, huge thing and you strike out everything and whoa! I'll show you what that looks like in a minute. If we want to kill off a unit, what unit do you want to kill off first? Hours or centimeters? Because we have to kill them both, right? We're changing to kilometers per hour. Oh no, kilometers per second. Alright? So, we have to kill off both those units and replace them with a different unit. The final number It'll be the same speed. It has to be the same speed. We're only going to be multiplying by special cases of 1 to do this. But somebody pick a special case of 1, or pick a unit you want to kill off first or something. This is arbitrary, it doesn't matter.
Centimeters.
Centimeters, let's kill off centimeters. See, in order to kill off centimeters and to get into what unit? Kilometers. What special case of 1 do we have to multiply by? Now, a trick could be, if you're not sure, you could do it a step at a time instead of jumping from 1 stair step to 3 stair steps. So there's a couple different ways to do this. We could either figure out, hey, 1 kilometer equals this many centimeters, or we could figure out 1 kilometer equals this many meters, and then 1 meter equals this many centimeters, and do a couple of tricksy multiplications where we multiply by a couple of different special cases of 1. So let's start with this. 1 meter equals how many centimeters? 100. If you didn't know that, you could go down 2 steps. 10 decimeters, 10 centimeters per decimeter is 100 centimeters. So we could get into meters right now pretty easily, right? By multiplying by a special case of 1. How many meters in a kilometer? Meters.
1,000.
1,000. Kilo in Latin means 1,000, by the way. Times 10 is 10, times 10 is 100, times 10 is 1,000. The other trick is just add a 0 for each step. 1, 10, 100, 1,000. 1 0, 2 zeros, 3 zeros. If there are 100 centimeters in a meter, in 1 meter, and there are 1,000 meters in a kilometer, then how would we figure out how many centimeters there are in a kilometer? Yes. Which is, multiply it the other way and you'll get the answer real quick. 100 times 1,000 is, 100 thousands is also known as 100,000. Okay? Remember, everything's equal to everything else. We're just changing how small the thing we're measuring with. That's it. Okay, so 26 centimeters per hour. If we want to kill off centimeters and get straight to kilometers, what would we do? What do we need to put in the bottom to kill off centimeters? Do you agree? Okay, why?
Because you have to have a different unit to kill it off.
Well, what happens when we put a 5 in the top and divide by 5 in the bottom? What can we strike out?
Nothing.
Nothing?
Both of them.
Because you can strike out a thing if it's both in the top and the bottom, right? So if we want to strike out centimeters on the top, what do we have to put on the bottom? Kilometer. Oh, really? Okay, let's try that. How many centimeters in 1 kilometer?
100,000.
100,000. Now what happens if we multiply straight across? Are we going to kill off centimeters? No, we're going to get double centimeters. Now, did you make a mistake? Is that okay? Totally normal. You did the same thing I used to do. All you do is identify the unit you want to kill and put it on the opposite side of the slash. Okay, so we're going to put centimeters down here. Now, what do we put in the top? What do you want to switch to?
Kilometers.
Kilometers. So 1 kilometer equals how many centimeters?
100,000.
Ooh, those are big numbers, it's scary. Now, what happens when we multiply through? What's the first thing we can do here? Can we kill off the unit we wanted to kill? Good. Are we left in a unit that we wanted to get to? Yeah. 26 times 1 is what? 26 times 1 is what? 26. Our unit is kilometers per. Now, did we get rid of hours? No, so we're still per hour. So that part's wrong. But now our top part is actually converted. We've done that. This is what I mean by do it a step at a time, okay? How are we going to kill off hours? This one I usually do in 2 steps. Because I don't know off the top of my head how many seconds are in an hour. But you know what I do know is in an hour? Yeah, how many minutes are in an hour?
60.
So what special case do we want to use to convert to minutes? If we want minutes in the bottom, and we want to get rid of hours, where do we have to put hours on this side to kill off hours?
The top.
The top. See? This is why it's important to make mistakes, because now you did, and now you're like, won't make that mistake again. Now you remembered. That's it. That's all that's happened. We're failing forward. It's okay. 1 hour. How many hours in a minute? Well, how many minutes in an hour? Actually, how many hours are in a minute?
0.6.
Not quite.
0.06.
Nope. You're not understanding decimal diffraction come up. It's 1/60th, which is a different number, right? It's 1 divided by 60. Right. I know. I've done the same mistake. 60 minutes. Ooh. What did I screw up just now, by the way?
It's. You need to flip it, don't you?
Before that, go backwards. I screwed something up. I made a mistake in multiplication back here. I did the top right. I'll give you that hint. I just got rid of a number willy-nilly without.
100,000.
Yeah. This isn't 1 hour. This is how many hours? Yeah. Now hold on before you make that face. 26 kilometers per hour is what I'm saying we're doing right now. Does that sound like 26 centimeters per hour?
No.
Or way faster? Uh-oh, Chester screwed up and didn't do a gut check. But 26 kilometers per 100,000 hours, that sounds really slow. Wait a minute, did we start off in something really slow? Well, good gut check then. Okay. We're gonna multiply across. I'm gonna bring that down here to 1 hour over 26 kilometers. Oops, sorry. 26 kilometers per 100,000 hours. 1 hour over 60 times 1 hour over 60 minutes equals, we can go straight across. What's the first thing we can do?
Cancel out the hours.
Cancel out the hours. That's the thing we were trying to do. Now we're up to 60 times 100,000 on the bottom in minutes, and 26 kilometers on the top, which stayed the same. That's good. We want that. 60 times 100,000. 60 100,000. What would be 10 100,000s?
What are you saying?
We need to multiply 60 by 100,000. This is how I do math in my head. Wait.
1 million?
Calculator?
What would be 10
1
100,000s?
million.
Okay, so it would be 6 of those.
6 million.
Right, so 6 times 10 is the same as 60, right? So 10 times 6 times 100,000 is the same as 100,000 times 60. Now I know 10 times 100,000 is a million, and now I need 6 of those. That's 6 million. It's a lot. 6 million minutes. 26 kilometers every 6 million minutes. Does 6 million minutes sound similar amount of time to 100,000 hours? It should be about 60 times as much. In fact, not about, but exactly 60 times as much. Yes. So these numbers are getting crazy, but that still sounds pretty slow, right? Now we got to go to what unit?
Seconds.
Okay, now how many seconds in a minute?
60.
Where do we want to put minutes and where do we want to put seconds for our special case of 1?
Minutes on top.
Minutes on top. How many seconds is that?
60.
Now, I'm not, 6 times 6 is 36 million plus a zero is what that's gonna be. And I'll tell you what I just did. 26 kilometers. We're killing off minutes, right?
Yeah.
I hate that minutes and meters have the same symbol. It's really confusing. So we killed off that. We're in we're in kilometers per second. Is that what we were going for?
Yeah.
Okay, what I would do here is 6 times 6 is what?
12.
Oh, 36.
6 times 6 is 36 million, then add a zero. 360 million. Seconds. Are we in kilometers per second? Does 26 kilometers every 360 million seconds seem really slow?
Yeah.
Now the question is it exactly equivalent to 26 centimeters every hour?
Should be.
Should be. If we multiplied out hours by 6 times 60 times 60, which is 3,600, we get 360,000 seconds. Times, remembering that we also have to multiply this. 26 centimeters is not very much of a kilometer, right? It's a tiny amount. That is actually correct. 26 kilometers. Now, there's one other thing we have to do though, is what? Can we leave a fraction like this? Yeah, we need to have a 1 in the top. That'll make more sense. Let's take out 2 and get down to 180 million. And that's 13 over 190 million. Actually, somebody just divide it. 26 divided by 360,000.
.000072222.
Every how often? Per second?
Yeah. Or no.
Point 0.0000722 kilometers per second. Okay. Does that sound like maybe, does point 0.00722 sound about like 26 centimeters? Maybe? Because there's 100,000 centimeters in a kilometer, right? This should turn out to be correct, by the way. Okay, is this equivalent to that, do we think? Does it sound pretty slow? Tens, hundreds, thousands, 10,000, 700 thousandths of a kilometer. Remember, this is 2600 thousandths, 700 thousandths of a kilometer every second. It's probably really close. That's probably right. Okay? Really close. We don't really close. Okay, now all that's, did that make sense? You know how it took a long time and it was really slow and now you want to skip steps? Don't skip steps. Because then you're going to get in the problem I had. So let's do one on your own now. Remember the 2 rules. Number 1 is
Yeah.
gut check. Number 2 is
Multiple by special ones.
special cases of 1.
Can you do one more together?
Yes, of course. What do you guys want to convert? Do you want to convert imperial to metric?
Sure.
Yes? Okay, you drive to Canada or anywhere else where they don't use imperial. Actually, the Brits still use miles per hour, I think. The Brits are kind of halfway, but they mostly switch. And you have to know, am I speeding or not? So, what's the normal speed limit on a highway in the United States? All of you drove here, so you better know this.
Normal?
Yeah.
Like on a highway?
Yeah.
Or like in 45?
On a highway? Have you ever been on a highway?
Like the interstate?
Yeah.
Like
Oh, it's
65?
65.
65. Let's use Van Halen's. Let's use from when I was your age. The speed limit nationwide led to a song by Van Halen. I can't drive 55. Because they were like, I gotta go faster than that because I'm a rock musician. Now let's do 60 miles an hour. Which my mother always liked to be able to go because that was 1 mile per minute. Oh, yeah, because wait a minute, you put 60 in the bottom, which is minutes and hours, and look at that, you just converted. Let's pretend that the speed limit in Canada is the equivalent of 60 miles an hour. Or no, let's pretend this. You're in Canada, and you see a speed limit sign. I had to do this, well, I didn't have to do this. I was in Ireland 2 summers ago and I was driving on the left. They've switched to the metric system, but they're still driving on the freaking left. On the left, and everything was in kilometers, but also the car I was driving was in kilometers, so I just had to match numbers. But pretend you drove your car over to Canada, so you're looking at this miles per hour that you're used to looking. Now most of them actually have both now, right? But pretend yours doesn't. And you see, oh, the speed limit's 90 kph, eh? Oh, kmph. The P is this line, by the way, kilometers per hour. Okay? In every hour, you're allowed to travel 90 kilometers, no more, or you're speeding. And something Canadian will happen. I told some people that I drove into Canada with, oh yeah, if you go to the hospital and you're gonna die, they just harvest your organs and give them to somebody else because it's socialized medicine. And they were like, really? And I was like, no, of course not. That would be crazy. Okay, 90 kilometers per hour. And you're like, all I've got is miles per hour in my car, I don't know what to do. We better convert it, okay? Miles per hour. Okay. Now, the first thing we need is a special case of 1 that you guys don't know. So I will allow you to look it up. What special case of 1 or what equivalents do we need right now? The only one you don't know. How many blanks in a blank? Yes.
So you want us to look it up?
Mm-hmm. Kilometers smaller, so you might want to say how many kilometers in a mile.
Okay, sounds good.
By the way, how many feet in a mile? It's like 5,280 or something. I don't know. I don't remember because the imperial system is stupid. And in kilometers is 1,000 meters because it's right in there. Kilo means 1,000. Now you see why the military uses it. Should be 1.6 something.
1.6009.
609.
Yeah.
Now, we should now be able to, we're going to say miles, by the way, because that would be a meter if this was. Let's start with personhood and the practice. This isn't punishment, but you asked for practice, so let's have you drive. Okay? We have 90 kilometers every hour. What do we need to multiply by? What special case of 1? What unit do you want to kill off first? Do we need to kill this one off?
Isn't it KM?
Yes. Do we need to kill this one off?
Top one first?
No, but do we need to kill ours off?
No.
No, we can say, so we can leave that top one only. That's the only one we need to fix.
Mm-hmm.
So what special case of 1? We want to kill that off. Where do we need to put kilometers?
On the bottom?
What special case of 1 is this?
That number?
That number, which is what?
1.609.
1.609, because there's that many. Remember, nothing changes size. This equals this. Those are the same, so when we convert, we'll have the same speed, so you won't get picked up for speeding, okay? Now, can we kill off can we kill off kilometers? Remember, we're converting so you can read your speedometer in your car, so you need to know what it is in miles. We're gonna put 90 miles for every 1.609 hours. Now, this should get us to the same speed because if a mile is bigger, okay, then you should be able to go fewer miles in 1 hour than you could go kilometers in 1 hour, right? If you went 1 mile in the same amount of time per hour, and a mile's 1.6 a kilometer, you're going way too fast, right? Does that make sense? Now we just divide this. Somebody divide that. 90 divided by 1.609. It's going to get a weird number. And then we can cross out these things.
About 55.93536636.
So really, we only had 2 significant digits we could use because there's 4 here, but you're only allowed to use the number of significant digits in the smallest measurement you have, okay? And the smallest number of significant digits. In that case, that's 2. So it's 56, we would round up. 56 miles an hour. Which is pretty close to so in Canada at that time it was about 9. Anybody know why nationwide? Here's a history lesson. It was 55 miles per hour. I'll give you a different clue. When my father was a child, which was during World War II, nationwide, by federal law, the speed limit was 30 miles an hour. It does have to do with the fact it was during World War II. Remember, the P means put down a slash. What happens when you go more slowly? What do you save?
Gas.
What did we need to fight the Nazis?
Gas.
30 miles an hour was the speed limit during World War II. You also could not buy a set of tires during all of World War II, because all tires for the war effort. It was crazy. It's all sorts of wackiness. So, this is just a history lesson. Up until, especially through the 70s and 80s, this was the federally imposed speed limit everywhere. It's for a similar reason. To save. Yeah. And it was because we were having something called an oil crisis, where the Gulf oil states, who produced most of the oil at the time, were getting together to try to raise oil prices by shutting down oil production. So the United States, in the 70s, when I was a baby, you had to wait in line to get fuel because there's just a shortage. We didn't have enough. And so they imposed this, in part. Somebody check me on that. I might be not entirely right on that. That's my memory, to save fuel for the nation. Okay, we only did a 1-factor change. Do you want another practice, or you want to try one?
Try.
What happens if you make a mistake? Everybody dies! No, actually it doesn't happen. We're fine.
Yeah.
We learn and we move on. So it's okay. Okay, what should we convert? You want to do within the metric system?
Yes.
You want to do other speed, since we've been doing speeds?
Yeah, this is
So
sweet.
we're doing speed. So how about how fast, anybody run in here?
My
Anybody an athlete?
mom does.
About how fast do you think she can run? 60 miles an hour?
No.
No.
Probably like,
That's a
she
good
can
question,
run
right?
like an 8-minute mile. I don't
An
know.
8-minute mile.
Yeah.
1 mile every 8 minutes. Ooh, we could convert that to miles an hour, huh?
Mm-hmm.
Convert that to miles an hour. Well, then we'll convert to kilometers an hour in a minute. And then somebody's going to walk me through what they did. I'm not going to do it. if you come up with, she can run 480 miles an hour, you're gonna immediately be like, that doesn't seem right. Unless your mom is the Flash. Remember, all you're doing is special cases of one. And in this case, we're only changing the bottom unit to hours. What unit do you want to kill off?
Minutes?
What special case of one do you need then? Good. How many minutes are in an hour?
60?
Okay, what goes on the bottom?
1 mile?
Well, no. 60 minutes divided by 1 mile isn't 1. 60 minutes divided by... Remember, you're multiplying by a special case of 1. Good. You lost.
Lost.
Okay, it's okay. What special case of, what do you want to convert to?
Hours.
Okay. What do you want to kill off?
Minutes.
So you're right to have minutes in the top. How many minutes are in 1 hour?
60, so I put 60 right here.
Mm-hmm. All your, remember, rule 1 was a gut check. How fast should this be? What's rule 2? All you're doing is
Yeah.
multiplying by some special case of 1. The hardest thing is just figuring out, hey man, what special case of 1 do I need? Don't ever be afraid to do the following. This is one of my tricks that I always did on tests, and I'm good at tests, okay? When in doubt, write down the stuff you know. I know I'm converting to hours, and I'm from minutes. I know there are 60 minutes equals 1 hour. Does that help? Fall over this chair. Doesn't help me.
This doesn't seem like it does right.
Okay, what'd you get?
That's 6 miles an hour. Seems a little too fast.
You crossed out your 8 for some reason. How come?
Stuck right here. Cause that's minutes, and I'm trying to get rid
The
of.
only thing you can cross out is the unit in that case. You don't get to cross out the numbers, lady.
Oh, that's, okay.
You did do something wrong, but that's okay. That's how we learn. What'd you get? Y'all can use calculators
Sweet.
to inevitably divide what by what.
So you can.
Okay, it's okay. It's one thing to see it done. It's a different when I tell you it. Yeah.
Okay.
Now, you've gotten rid of everything. So over here, this carries across 60 miles per.
Okay, I have that.
Yeah, you weren't stuck. You just doubted yourself.
8.
Now here's a question. Let's stop right real quick. If you think she can run a mile in about 8 minutes, do you think she could run 60 miles in 8 hours, which is about 60 times the number of minutes? No?
I don't think.
Wait a minute. If she can run 1 mile in 8 minutes, why can't she run 60 times that far in 60 times that long?
Well, I guess she could, because you acting like
If
you're
she
right.
could keep up, no, if she could keep
If she
up
could
that
keep up,
pace, then that should be the same, right?
Yeah.
Okay, you're in the right track. Now you just divide that by that.
Close.
What? Wait. Can I borrow this? Can I write that down?
Yeah.
That's
Wait,
miles,
this-
right? Oh, this is your answer?
Yeah. That was what you demonstrated before.
7.5. You don't have a unit up here.
Oh. I need to do
Now, we were changing.
7.5.
Oh, from minutes to hours. Does that sound right?
miles per hour.
If you could run 1 mile in 8 minutes, how long would it take you to run 7.5 miles?
I learned
Maybe.
It sounds close.
It's not.
this.
Gut check sounds close to me. What'd you get? Okay. Starting to be evidence that you may be right. Someone has checked your experiment and they've gotten the same answer.
Okay.
That's good news. What did you two get?
7.5.
Uh-oh. What'd you get?
What'd they get? What'd you
Same thing.
Everybody got 7.5.
Oh.
Ooh.
7.5.
If 4 people independently did the same experiment following the same rules and got the same answer, would
That's
we
probably
begin, yeah, we begin to think, maybe that's right, and in fact, 7.5 miles every hour. Now, let's see if that's equivalent to 1 mile every 8 minutes. The the real question you have to ask yourself is, if she goes 7.5 miles an hour, how many 8s are there in 60? Guess what it's gonna turn out to be? Multiply that and see what you get. 8 times 5 is 40. But 5 times 8 is, no, you did it the other way. That's what I did wrong. I had it right the first one. I haven't multiplied by hand in a while. 8 times 5 is 40, 8 times 7 is 56, 60, there's my decimal, 60 minutes. Huh, what do you know? Everything equals 1, or everything equals back to itself. So about 7.5 miles an hour. Does 7.5 miles an hour sound like a reasonable speed a human could run?
Mm-hmm.
Yeah. Now, you know what the most famous record for the mile was that somebody had to break, that they thought nobody could do it?
Like fast? Like
Yeah,
what?
the
It's
fast.
like 3 or 4 minutes.
The
right?
4-minute mile was a barrier.
Yeah.
The 4-minute mile was this barrier, and nobody could break it.
Yeah.
Now, if you think about that, how many laps around the track do you have to go a mile? 4, because a track is a quarter mile.
Mm-hmm.
Do you think it's reasonable to say somebody could get around that track in 1 minute?
I'd say so.
Yeah, that's a real typical speed, under a minute. If you're a quarter miler, that's your race. 1 lap. If you're under a minute, if you're way over a minute, you should get another race. Or work a lot harder, whatever. A bit under a minute. Now, just like you earlier were like, oh, could she keep up that pace?
Yeah.
That part's hard, right? So keeping up that, people could do a quarter mile in under a minute, but doing 4 of them back to back, nobody could do. Until a guy named Jesse Owens did it in, I don't remember when, 70s. Somebody look it up. I think it's Jesse Owens, see if I'm remembering that right. You guys use your third lobe, it's so nice to be able to just check things. I had to remember all this stuff.
Wait, what was his name?
Jesse Owens, I think, or just ask who wrote the 4-minute mile. This is an interesting thing about human psychology, by the way, we're going to learn. real quick.
2009?
No.
wait.
Yeah?
1954?
1954? Could be.
Sir Roger Bannister, I think that's how you say it here.
No, come on. This sounds like one of those things where the British think they did something before us. Roger Bannister? I thought it was Jesse Owens. In popular culture.
This is Usain Bolt can run it in 2 minutes.
No, not
Don't
possible.
you think he'd die?
You can't do it in 2 minutes. Roger Bannister? Somebody look up Jesse Owens and see who that is.
Jesse, that's when he pulled up. Top speed of 34.92 kilometers per hour, 21.7 miles per hour.
Huh.
But it doesn't tell me when.
I'm having a weird brain thing right now. I would have sworn my mother told me it was Jesse Owens. This is one of those classic cases where some authority figure told you something and you had just thought it was right the whole time, and now I'm having this cognitive
Wait, no.
dissonance.
In 1935, Jesse Owens made sporting history when he broke 5 world records.
Including the 4-minute mile?
I think so. It's his Olympic statics.
But does it say he broke the 4-minute mile?
Let me look. It's a list of his.
Yeah, these all say Roger Bannister.
Crazy. Roger Bannister. Four-time gold medalist Jesse Owens. This is one of those things where my mother told me a thing that just wasn't true. Yeah, he didn't even run the mile. Okay, Chester learns a thing today. Wow. Here's the interesting thing, regardless of who it was. I actually know why this happened now. I'll explain why in a minute. But so Roger Bannister, apparently, first person to break the 4-minute mile. I'm glad I know that now. My brain is broken. Right after, nobody could do it. Then he did it. Then everybody could do it. Like, not everybody, but suddenly all sorts of people were doing it. And this is kind of a famous human psychology story. That once someone proves that it's possible, suddenly in a weird way, it's like a barrier that breaks for everyone else, and everyone else can do it now. Now, Jesse Owens was interesting for the following reason, and this is probably why my mother thought it was Jesse Owens, and then I'll tell another funny quick story. Jesse Owens was a black athlete, I believe, somebody check me on this,
Yeah.
during the Olympics that was held in Germany while the Nazis were in power, saying that the white race was better than everyone, and he went over there and kicked the crap out of the white race. My mother taught. My mother was alive during that time. My mother, no, she was born in 34, but she didn't know who Jesse Owens was. She taught in an all-black girls' school during segregation, when it was illegal for white people and black people to be in the same school. She was a teacher in a school, all-black students. And I'm sure she crossed up in her mind the accomplishments of Jesse Owens, the 4-minute mile. That'd be my guess. And she told me that, and I always accepted. My mother was a teacher, so of course she would know. Man, it's been in my head this whole time. Now, I had to go home and tell my wife this because I made fun of my wife. This is why I always pay. When my son asked, who is Pele? Anybody ever heard of Pele? Very famous Brazilian soccer player, and my wife said, he invented soccer. And I was like, what? She's like, Pele invented soccer. I was taught that in school. Soccer's been around for like 1,000 years. Pele might as well have invented soccer for how good he was, but I made all sorts of fun of her, and now I'm gonna have to go home and eat crow because I thought Jesse Owens was the first person to break a 4-minute mile. Thanks a lot, Mom. Okay, let's do another one. I'm just gonna write a random thing. 26 meters per minute. No, 26 meters per second. 2 centimeters per hour. And then, pretty quick, we're going to be done. Because now it's going to be time for you guys to practice. I've taught you how to play the piano, and you're like, oh, I see how that piano is played, but you won't get any good at it unless you go practice. Think about what special cases of 1 you need to multiply by. Sorry, we had some trivia in there that took up some time. Remember, you can use this. I'm going to start with a gut check. About how fast is 26 meters every second? Fast or slow? About how far is 26 meters? If you think a meter is about the same as a yard, pretty close. That's like a quarter of a football field in a second. More than. Pretty close to a third of a football field in a second. So maybe faster than running speed.
So 1 meter would equal 100 centimeters, correct?
Here's a meter. To get decimeters, which is tenths of a meter, you multiply by 10, and then to get centimeters, you multiply by 10 again. So 1 times 10 times 10 is? Correct. Sorry for not just telling you the answer, but what I want is for you to know how to do the thing I just did. Remember, pick a unit to kill and convert to, then do the other one. Do a gut check and figure out what special cases of 1 you need to multiply by. That's all we're doing. If you think 26 meters per second is relatively fast, or you can get a feel for about how fast that would be, well, it better be that same speed at the end, right? Because we're not changing distances and we're not changing time. Now I gotta ask my brother and sister who they think meters.
I cannot be doing this
Do what? Say again?
right. I cannot be doing this right.
Okay. Well, what are we doing?
Can you really big number?
Getting a really big number. Okay. Well, let me see what you did.
Is that big or not?
That's
Well,
right.
how did you get there? Okay.
Right there.
Is there 100 centimeters in a meter?
Yes, okay, so we're gonna have seconds right here. And I'm trying to get with the acceleration hours, so up here, so right.
If you're going to kill off seconds, you need to have, how many seconds are in an hour. But yes, you could do that. How many seconds are in an hour?
3600.
Why are you getting 3,600?
So I'm converting seconds to an hour.
How are you doing that?
So I did
Seconds to minutes and minutes to an hour.
Yeah, tell me what you're doing there.
60 times 60.
Is that 3,600? Just because I ask you doesn't mean you're wrong. I'm just
I
asking you to
think
double
that's
check.
3,600.
That's correct. 3,600 seconds in an hour.
But,
What I usually do is convert to minutes and then convert to seconds, just because I know it's 60 and 60, but she's right, it's 3,600 seconds.
Right here.
Yeah, are you killing off seconds? So you want to put seconds in the top. Special case of 1 in 1 hour, good. So you're going to kill off hours. Or no, you're going to convert to hours.
So then I want to multiply that.
Yeah.
That's really large.
Okay, well, remember, let's think about a third of a football field in a second. Could you run that fast? Could. That would be from one end of the football field to the other in 3 seconds. Could any animal run that fast? Probably not. This is pretty quick, right?
Oh, actually that seems not right.
Gut check. What'd you get? Wait,
I think
let everybody else finish. Is everybody finished?
Or wait,
She's still working.
is there
People
another-
still working.
I'm just stuck. I think I might be done.
Okay. Where do you think you're stuck? This, I knew 3,600. I was confident in it.
Right there, I don't know what to do.
But how did you get to there?
I just did.
What goes under here? This isn't a special case of 1. 2,600 centimeters divided by nothing is 2,600 centimeters. How did you get from here to here? You are skipping steps, just like I told you not to, because that's how I always screwed up. Start with that, split pages, and start with that, and don't skip steps. Because I can't tell where you, here's the thing. If you write all your steps, I can tell where you made your mistake, and I can go, she was really good right to here, and so I can give her partial credit. But also, don't do what I did and skip steps, because that'll mess you up. Just multiply by a special case of 1. Now, what unit do you want to kill off first? Meters?
Sure.
Okay.
Yeah.
So 26 meters per second. These are cool pens.
Thanks.
What special case of 1 are you going to multiply by now? Well, what do you want to kill off first, meters or seconds? You just have to pick one, it doesn't matter.
Meters, I guess.
Okay, so where does meters need to be in your special case of 1? Write a multiple. Okay, meters on the bottom. How many centimeters in a meter. So 100 in the top, 100 centimeters. There are 100 centimeters in every how many meters?
1.
Okay. Can you kill off meters?
Yes.
Okay, do that. Now, that's how you got to 2600, which was correct, but I want to see the work. Equals 2600 centimeters per second. The reason you're doing this is this. Inevitably, you will eventually make a mistake. And you'll do your gut check and then you'll go like, oh, that doesn't seem right. Then you can go back step by step with what you wrote and find, oh, that's where I made my mistake. Correct the mistake and work your way out of it.
Okay.
Now, you gotta kill off seconds, so times what?
Seconds.
In the top. Per, what are we converting from?
Hours?
Oh, yeah, we're converting, I'm sorry, what are we converting to? We're converting to hours, so hours in the bottom. How many seconds in an hour? You told me this earlier.
3600.
Yeah. Now, what did you say when you got to that point? This seems really,
That seems really large.
yeah, per 1 hour. Now multiply across. You can kill off seconds. Okay, 1 second. Remember, we're converting to centimeters and we got a quick speed. And we're converting from a much bigger unit to a much smaller unit. So just like going feet to inches, you would expect there to be a whole lot more of them, right? There better be a whole lot more of them because we have to measure like this instead of like this. Chunk, chunk. We go like, you better have a bunch of those little meanies to get there, right? Rule number 3, have a bunch of meanies to get to the. Okay, so what'd you get?
9,360,000.
9,360,000 centimeters every hour. So let's look at it this way. If you went 26 meters every second and you did that for 3,600 seconds, multiply 3,600 by 26 and you'll get the number of meters you could go in a second.
$93,600.
That's a lot of meters every hour, right? Now, to get to centimeters, it has to be 100 times that. What was the answer you got?
9,360,000.
Is that 100 times that last number? Bam, there you go. That's fast. 26 meters a second, which is pretty fast. Now, where someone just said they had a mistake or they wanted to do something or had questions, you suggest questions.
Oh, can we use a calculator on our test?
Yes, but show me
Your work.
your work.
Okay.
2 things about showing me your work. 1, I want you to practice doing it. Don't skip steps. It's so tempting, I know. I used to always do it. You know when I stopped? Literally when I stopped? You're not gonna believe it. You know when I stopped skipping steps?
This morning.
3 years ago when I started teaching chemistry. Because I didn't want to be the teacher who was like, I got that totally wrong. So I wanted to be really careful. You be really careful. Do a gut check, multiply by special cases of 1. I guess the 3rd rule is do all the steps. Don't skip steps, let's say that. Don't skip steps. It's so tempting. But don't skip them, okay? Don't be a Chesser. Can't imagine how many times the other teachers say that. Don't be a Chesser. Okay. So that's fast. You guys think with some practice you can do this now? Okay. I want you to go home and look up Khan Academy unit conversion, and they'll have just Khan Academy unit conversion practice, and they'll have practice. Also, if you want to watch Khan Academy, he'll show you this in a little bit different way. And maybe you'll go like, oh, Chester's sucked, but this is better. I don't care as long as you know at the end, that's fine, okay? Do some practice. Now, you think that's fast. I'll tell you one last science interesting factoid before you leave. Do you know what the International Space Station is? The ISS. Have you ever heard that?
Yeah.
What is it?
I don't know, space station?
It's a space station that orbits the Earth, okay? See, people think that when something's in orbit, this is the Earth, they think little astronauts are up there like this. But that's not what they're like. That's not orbit. Orbit is this. Really fast. Because if you were just sitting there, you'd immediately fall back to the planet, according to all the rules of everything you've ever heard of before. If you let something go, it falls. In order to stay in orbit, you gotta be going around really fast. International Space Station, which is continuously manned by scientists from all over the world, international, 2 nations, orbits in a fairly low Earth orbit, and the rule is the closer you get, the faster you have to go, just like the more the skater pulls in his or her arms, the faster they go. So, this is how fast it's going. Go back to our football field. You're standing at the end of the football field with a rifle. The International Space Station's going over your head, right as you pull the trigger. By the time your bullet gets 10 yards, International Space Station's past the end of the field. That's fast. And it's kind of cool because if you pull up an app on your phone, you can actually see it. If you catch the sun glinting off of it, right, you can see it at night. Like the sun will shine off of it. If you get an app on your phone, it'll actually tell you where the ISS is at any given moment. It's overhead right now. Look over here, and you'll see it zipping by. It's kind of cool. Does anybody have questions? Was this helpful? Was it too long? It's okay to say
I
yes.
thought it was
That much thoroughness was needed. Great. Have a great day. Thank you for your participation. Now, all of you have tests and DBAs coming up. Does anybody have a DBA with me today? Okay. Even if you go past, I know the rule is you can't take your unit test late. That's not the hard and fast rule. If you are working really hard toward it and you're close, you're just going to take it, okay? It'll go to 0, but don't freak out. You still get to take it. Okay? Just take it soon.
Will we have any type of like key on the test like that?
No, but if you take it proctored, I need to add that. If you take it proctored with me, or if you take it proctored, remind me to add to GoGuardian so you can go to this.
Okay.
Okay? You may use this regardless. Okay? You may always in a chemistry test or any science test, you may always use the periodic table of the elements, and you may always use a converter one. You probably can always use this. I don't think there's going to be a time when I ask you to memorize this. But this isn't super hard to memorize if you'll look at it a little bit. But that's what a table is for. Why memorize it? I had to memorize the periodic table when I was your age, and it's like, why make a table then? Like if I just know it all, there's a lot of stuff in there. All right, ladies, thank you. Have a great day. Get a hold of me if you need help still, okay?
Okay.
And thank you very much for being my first set of
Do
guinea
you want
pigs.
me to stop recording?
Please.